Hey, g'day. I think this is part 7 of the Solar Shared series. So this one I'm looking at the coding I'm going to use in Angular to get the web interface to remotely control the ham radio. So I'll start off, I'll just do a quick demo of the interface I put together, and then I'll have a look at the code I use to do that. It won't be an in-depth look at the code, just a reminder that I've got that GitHub link down below, so if you're interested in any of the code, all the code's in there. So it may be easier to show the end result first. So I'm running this on my test setup, so not the one in the shed. So I've got the Raspberry Pi 3, which is called RPi 3, a relay, and the micro SDX transceiver all set up. And I'm running this on my iPhone, so just show a demo of running on the iPhone. So first I turn the rig on, which turns on the relay, and the interface picks up all the details from the transceiver. So the frequency, which is shown in this frequency control, the band, and I also show information about the band. So I'm just learning this ham stuff, so it'll help me work things out. Mode control, so change between carrier wave, upper sideband and things. And then finally the push to talk control to toggle between transmit and receive. So you can see here where I'm changing the band, and it changes the frequency, and both on the display and on the actual transceiver. Here's where I'm changing the mode, so going to AM, and you can see it changing on the transceiver too. And an example of using the press to talk, so you can see it switching between transmit and receive, and because I'm in carrier wave you can sort of hear the tone going at the same time, and then I can use the rig control button to turn everything off. Let's go back in time a little and look at the design and coding process. So it took me a little while to get kind of comfortable with using rig control and the cat interface and what my micro SDX transceiver could do. So last video I looked at rigctld, how that's used through hamlib to control the rig, and these are all the commands that are available. There's lots of them, but that's not the end of the story. So which of these commands are actually available depends on the capabilities of the interface to your transceiver, and then what the transceiver actually supports. So the interface to the transceiver uses TS 480 control set from Kenwood, and there's the link to the document about this, and you can see all the commands that Kenwood makes available to the cat interface. And I had to do some mapping of that, and then even though that interface, the TS480 interface, supports all these commands, my actual micro SDX doesn't implement all the cat interface commands. So I went to the software, and this is where you can find the software for the micro SDX radio on GitHub. And if you look down here at about line 4000, I think, or 44, you start seeing the section about cat support, and here you see the commands that are actually implemented on the transceiver. So again, not all the commands that you see in the Kenwood manual are supported, and I did a deeper dive in here, so I just brought up that same file in VS Code, so it's more colorful, easier to follow. So those are all the commands that it'll respond to. As just sideline here, it's interesting, they've actually got a cat extension command in there for doing streaming from the radio. So next video I may use that. I'll have to see how well I can get that working. But for the actual standard cat commands, you can start seeing how they're implemented here. So like get frequency shows you the actual code. So this gives you an idea of what's actually implemented. And you can see here on this printout, I actually tried to go through all those levels from the rigctld command down to what was actually implemented to see what what I had a choice of. And really it came down to basically using changing the frequency, changing the mode, and changing from transmit to receive, and maybe sending some dots and dashes are things that I can do through the cat control. Other than that, then I have to put the smarts into how I change the frequency and things into the Angular client. So I think I know enough now to implement an interface that will be useful. I can should be able to tune the transceiver, change its mode, change it into CW, and set it up for sending Morse. And also I can put some nice to haves in there as well, some smarts into the interface to make it easier for me to use as a new ham radio operator.
For my interface design, I'll just do it in Microsoft Sketch. So the first thing is I'm going to have some sort of frequency control. It was going to be the hardest bit, and it's going to have some digits in there. And I'll put some buttons up and above it, probably just up and down arrows, so I can press those to move the frequency up and down for that particular digit. I'll still have the rig button, so that's going to actually turn the rig on and off when I press that. The other thing I'm going to need is some sort of mode drop down. So mode is things like carrier wave or AM, or upper sideband, lower sideband. So it'll be the drop down control to do that. As well, I'll need to select the band. So it'll be things like, say, 10 meters, 20 meters, whatever frequency band I'm using. They'll tie into the frequency control so that when I select a certain band, it resets the frequency to the start of that band. The other thing I think I'll have is tied into the band will be just some text description of what you can do in that band, again, because I'm a new ham app operator. That'll be useful. And finally, I'll need some way of changing from transmit to receive. So it's normally done with a PTT control, so pressing that will switch the transceiver from receive to transmit and back again.
Hey, this is a snapshot of what the rig interface ended up looking like. This is what the interface looks like. So I wanted this frequency control done first. So the idea is it shows the frequency on the transceiver at the moment. Then I've got these little buttons I can push to increase or decrease the frequency. And the way I did this is in Angular, you use the component approach. So I sort of broke it up into components under the rig component. So I created this F control for frequency control, which is this part here, which actually shows the frequency and allows you to adjust it. And then the frequency control was made up of multiple digits, so I also made this frequency digit control below that. And the way it works is under rig, I set the value or the frequency of the frequency control. I also set a minimum and maximum value, because what I want to happen is when you're within a certain band, say this 10 meter band, that it doesn't go any higher, doesn't allow you to change the frequency to be any higher than what's within that band or any lower than what's in that band. So this minimum maximum value sets the minimum and the maximum that this value can change. So that's in the F control component, and the F control component also breaks down the frequency into the individual digits and contains a component for each digit. So each digit kind of looks like that. It just has the up and down arrows and the actual value it's showing for that digit. And that F digit control gets set by setting the value that it should be. So in this case, I'd set it to 2, and the scale that that digit represents. So whether it's in the millions, 10 millions, thousands, hundreds, I can set the scale. So that F digit control, when I make a change to it, if I push this up or down, arrow, it actually calls the on change event, which bubbles up to the F control, and that contains either a negative or positive value representing the scale. So whether it's tens, thousands, millions that the frequency should change, it gets bubbled up as a change amount, and the F control then updates the frequency or the value and then resets all the digits to represent that new value. Also, the frequency control will bubble up that event as well, so indicating there's a change in value. That gets bubbled up to the rig, and then the rig also will deal with changes to the frequency by updating the transceiver. So let's have a look at the code that's actually doing this. Okay, so we're now in the SOLARUI project, and you can see here where I've created the components F digit, F control, and they're used in the rig component. So F digit, let's have a look at that. So that's just a simple grid that has a button up and a button down, and displays the particular frequency digit between those two. And the TypeScript behind that, it takes two input values. So this allows you to pass values to that component, a value and the scale, like I said before, and will output an on change event. And let's see what's happening here. So when it starts up, it sets the internal scale to whatever was passed to it. If I press the value up button, it does just emits the current scale value. If I do a value down, it emits a negative version of the current scale value. So the digit control is pretty simple, and then if we go up to the frequency control, we see here that it contains multiple F digit controls in it, representing each digit that's displayed and its particular scale. And for want of a better name, I just called them value, whatever the scale value was, to help keep track of them. Then in the code behind that, we see it takes three inputs, and we saw that before. It takes the actual frequency value and a minimum and a maximum value frequencies for the band, so it doesn't go out of the band when I'm clicking up and down. And again, it outputs an on change event when the frequency changes. You see here where the update frequency value is called when one of the digits sends an event to say that it's been incremented or decremented in one of the digits. First, it checks whether it's within the bounds of the minimum and maximum values. If it is, then it allows the change to the digits, and then emits the new frequency value. The value is converted to the display digits using this routine, this set digits. So let's have a look at set digits. So basically, it makes a string representation of the particular frequency. So and it does padding with zeros in the front, so it'll be a 9-digit representation of whatever the frequency number is as a string, and then each of those string values from the left to the right is passed to each digit component to set the component. So hopefully that frequency control is fairly simple, and then we see where it's being used up in the rig. So in the rig, for the frequency part of it, we see the frequency control here where we set the rig frequency, the band minimum, band maximum, and what processes the on change event. And then down in the actual TypeScript, we see on frequency change, this is the routine that calls out to the rigctld routine to set the frequency to whatever the new frequency is, updates the frequency, and then redisplays all the rig settings back on the rig page. So it'll pick up everything: mode, frequency, current band, all those things, and display it there. Some of the other things that are happening in rig is based on the frequency. It will show band information. So it takes a frequency, gets this band info item, which is band info for that based on that particular frequency, and then displays various things on the rig page based on the band information. So basically the band and the band description information, and also will reset the values for the frequency control, the minimum and the maximum, based on what band it's in. So this bit's probably interesting, getting this band info item. It calls a helper function, so I set up a helper function down here in the services. So it was just a general helper function, so I can put any code that I can't think of anywhere else to put into the helper function. So I made these routines to get this band info item based on by the frequency, by the sequence. I have an internal sequence number for each band, or by the band, so I can put, say, 10 in here to get the 10 meter band information. And that information's coming from a model I set up here called band. So the definition of the band info item is it has a sequence number, like I just said. That's really just an ID for that particular band. Band as a number, so this would be 10 for 10 meters. A name, so this would be the actual name in long form, so I'd say 10 meters, 20 meters, 80 meters and things. The start frequency for that band, the end frequency for the band, and this bit to help me up, how does a new ham operator, as a description, so it displays some helpful information on the Angular page as well about that particular band. So you see examples of particular band information, which I implemented as an array of band info items. So for example, for the 80 meter band, its sequence is 8, band is 80, name is 80 meters, starts at 3.5 megahertz, ends at 4 megahertz, and then the description is useful information about how to use that band, so what type of transmissions is allowed for sub frequencies in that band, and who can use them. So T would be a technical operator like me, but there's general and other sort of operators as well, so the information for them as well is shown there. So I just basically did that for each band to help me out when I'm trying to use the transceiver to remind me what frequency I should have things set up at and what mode I should be in. Otherwise, I think that's most of the code for the rig. Let's just have a look. I implement things like the band as a material select drop down. So basically, again, using the band information from that model we just looked at. You can see it here, doing an NG4 to populate the drop down select box. A mode, so the various modes that my transceiver supports, so carrier wave, upper sideband, lower sideband, and so on. So it's just another drop down that used to select that. And you see all these call like an on mode change, on band change routine to actually get the changes actioned by the code behind. So again, calling rigctld to set modes, set bands and things. So the last thing I put on here was a push to talk option, which is again just a material button that flips between being in transmit or receive mode, and it's calling the on PTT routine. And you can see the on PTT routine here is basically using the set PTT, which is again is a rigctld command to toggle the current setting for the rig PTT to swap it between transmit and receive. So that's most of the code for getting the remote control going. The only other thing I need to do is be able to stream audio to and from the receiver remotely. I'm going to leave that for the next video because that's going to be a bit of exploring first before I work out how to do that. Ideally I can do it from the web interface as well, but if I find that too hard I may just have the streaming run off a separate program on the program that I'm running remotely, but hopefully I don't need to do that. Hopefully I can use some of the functionality in HTML5 to be able to stream directly to the web interface. So one other change I made to the Angular interface here was nothing to do with the rig, but find out more about what's going on with the solar charging. So you've seen this one before. I think I showed in one of the earlier videos how I created this as a chart showing the battery level, the solar watts been coming into the system and watts going out, and that was allowing me to see trends over time. But I wanted to see a bit more about what was actually happening with collecting energy off the panel, so I added this panel component here, and what this shows is the change between charging modes for the panel and the controller. So it shows me whether the panel's not making any energy at all, whether it's in boost charging mode, where it tries to fill the battery as fast as it can, that the battery's low enough that it needs recharging with as much energy as it can get off the panel, or whether it's in float charging mode, where it's the battery's basically reached maximum energy 100%, and now the charging controller is just maintaining charge. So that sort of tells me how effective the panel is at charging the battery, and I can look at that over time to see if there's changes. So I can see here where there's a couple of cloudy days where there wasn't any floating going on, and the actual power coming off the panel on those days was fairly low. But it's also useful for seeing during the day. So this blue line here is showing the number of volts that are being seen on the actual panel, and this is a good indicator of like the sunlight that's actually hitting the panel, and when it's getting the maximum sunlight and energy possible from the panel. It doesn't always use all that energy, so if the battery's already almost full or it's in floating mode, then it won't convert that into the maximum amount of watts. If the panel doesn't need it, it's not seen as watts. It'll throttle the number of amps that are going to the battery. But this is just the raw voltage seen on the panel. Gives me an idea of when it's sunny during the day, and helps me position the panel to see where's the best place to put the panel to get the maximum energy if it was using that energy. And then whether it's float or boost mode tells me a bit more about whether I'm filling the battery as effectively as I want to. So basically I put this onto a new component called panel, just show things that are related to the panel mainly. So what's the power coming off, the number of amps, and what's the voltage, which is important in the current charging mode, were the main things I need to know about the panel. And then it's the same as the other control, where it can either show me 24 hours history, 7 days history, and you can kind of see here where those 2 cloudy days were, 14 days history, 30 days history. To add this in, I had over in the Solar www I had to make changes, and in the Solar daemon I had to make changes to store this extra solar panel information and the charging mode information so I could display it. So that's the reason I've only got about 10 days worth of history at the moment, but they'll be useful over time, especially as the seasons change, to see as the sun moves through different seasons, what's going to be the most effective place to place the panel and collect the most energy from the sun by looking at the voltage hitting that panel. So that's about it for this video. Next video I'll have a look at how I'm going to stream audio to and from the the transceiver, hopefully to the web interface. At the moment, I'm not quite sure how I'll do that. I've got some ideas, but I've got to experiment a bit before I find out what works best for me. So I'll do that in the next video, and that'll just about wrap it up. So after that, I'll be able to have the solar shed up and working with a ham radio in it. So I'll have one more video up after that just to wrap things up, see how I put a aerial on the shed, and maybe some demonstrations of doing ham stuff remotely, and looking at the long term how the solar panel's been going for managing the whole thing.